Why would anyone build a bridge this big? Not because they wanted to, because they had no other choice. This isn't just another suspension bridge. Every part of it, from its massive towers to its enormous deck, had to be pushed far beyond what engineers normally build. But making it bigger created an even more dangerous problem. The heavier it became, the harder it was to keep stable against powerful winds, earthquakes, and one of the busiest shipping routes on Earth. So how did engineers solve a problem that seemed impossible? The answer involved some of the tallest bridge towers ever built, thousands of miles of high-strength steel cables, and a construction sequence where one major mistake could have delayed the entire project. Let's go inside the world's most extreme mega bridge. At first glance, it looks like just another suspension bridge. But there's one detail that makes it completely different. Most suspension bridges carry cars. This one was designed to carry an 8-lane highway and a high-speed railway on the same deck. That single decision changed everything. The bridge suddenly became much wider, much heavier, and far more difficult to keep stable. Engineers couldn't simply build a bigger version of an existing bridge. They had to rethink almost every part of the design. But before any of that could happen, they faced an even bigger problem: the towers. Each one would rise higher than many skyscrapers, and they had to stand on the edge of the Bosphorus, a narrow strait known for powerful currents, unpredictable winds, and constant ship traffic. There was almost no room for error. So how do you build towers of this size without stopping one of the world's busiest waterways? The answer began with a massive operation hidden beneath the surface.
Line it up with the marker, hold it steady on the left. Ready to tighten the flange. Verified, torque it down. All right, load it up. Ready the next section. Watch the cable, steady. Clear the lane, let's move. The readings are all within spec.
The drainage passed without issue.
Let's sign off on this.
So why is this bridge so big? It wasn't built to break records. It was built because there was simply no other engineering solution. To carry 8 lanes of traffic and a future high-speed railway across one of the world's most challenging waterways, engineers had to make everything bigger. Taller towers, stronger cables, a wider deck, and foundations capable of withstanding enormous forces. Every extra meter had a purpose. Every extra ton solved a problem. And that's what makes this bridge extraordinary. Not its size, but the engineering decisions hidden behind it. If you enjoyed discovering how engineers turned an impossible challenge into reality, don't forget to like the video and subscribe. Because in our next engineering mega project, we'll go inside another incredible structure that pushed the limits of what's possible. And the story behind it is just as unbelievable. Thanks for watching, and we'll see you in the next one.